There we go.
Jeez.
No, it's good. It's okay.
All right.
You'll just have a silent first half.
Yeah. Okay. Before we go forward, are there any questions on the stuff that we covered? We're going to be working through a Node application example that does some HTTP requests, but like with anything I say, feel free to throw up a hand and ask any questions. But before we step forward, especially now, any other questions that came up before the break? Yeah. Both kind of do the same thing. So they let us try and test out HTTP methods. Yeah, curls with the command line, and then Postman kind of gives us a more an interface to do it. It also lets us save requests. It has some extra functionalities that like curl wouldn't have. So if I wanted to test out, say, 5 specific HTTP requests, I could save them and then work on them and then come back later and have them saved and just like run them all again. Yeah, just a bit of additional functionality that curl or like the browser options don't really like give us. So the next part we're going to be working through like a example. So I'm going to be coding up an example here. Feel free to like interrupt me at all times. I'm going to be trying to kind of clearly say what I'm doing, but if it's ever not clear what's happening, just like let me know. But our goal is to build a Node application that can make an HTTP request to a Pokemon API returning who's that Pokemon. So this API, click, oops. So this is like a API that someone else has offered, and it has a bunch of different paths that I can request different information. So for this example here, if I do Pokemon/Ditto, it gives me all the information on a particular Pokemon. The goal of our application is to give it a number. So if I give it 23, and I want my application to return like which Pokemon that is. So, oh yes, yeah. So I give it a number here, and then we can see this is like Butterfree. So our application is going to make a request to this type of URL, and then based on how the information we get back, we're going to process it and just like let the user know which Pokemon it is. So to start with, I'm going to create a new file. I'm going to call it who's that Pokemon, and I'm going to make it a JavaScript file. And then inside of our editor, I'm just going to open it up. So our goal, I'm just going to take this. These are our goals. So to start off, we're going to require the HTTPS library. So this is or module. This is a module that's comes with Node. I know last week we started towards the end using other modules, and we had to go npm install and specify. I think we used like Chalk, and that added it to our package.json and let us require it right inside of our code. With this case, HTTPS comes included with Node, so I don't need to specifically install it. So now that I have this, I want to have a function that returns, I guess takes two parameters, a Pokemon number and a callback function to return the data. So I can go function, we'll call it who's that Pokemon, and we're taking in two parameters, a number and a callback function. So inside here is where I'm going to want to make the HTTP request using this HTTPS module. And the syntax for that is HTTPS, so the module that I've required, dot, and this will be like the method. So in our case, we just want to get some information from this Pokemon API, so we're going https.get, and then this generally takes two parameters. The first one is the options for this request, and the second one is a callback that takes the response. So this callback function here will be executed once this request comes back, and it will provide the response of that request. For this particular one, the options I want to use are just this URL of where we're getting that information. So I want to do a GET request to pokeapi.co/API v2/Pokemon, and then I want to also give it the number as part of the request. So I'm specifically requesting from this API I'm adding this on to the end of the URL or the end of the path. So my path will be API/v2/Pokemon, and if I give it a 12/12, if I give it like a 2/2. Yes. Yeah. So the link is a string right now, and I'm with the plus sign concatenating on the number. So it'll be after that line like one string together with, for example, like 5. Without the, like if this was 5, it'll look like that after I've concatenated it. So then when this response comes back, one thing that I can do, I can check its status code. So response.status code. And I can check if it equals any of the status codes. So does anyone remember what the status code for like successful response was? Okay, nice. So I'm going to check if it equals 200, and if it does, I'm just going to let the user know. I'm going to say request successful. Ooh. And so we'll do our first test. First we need to call the function. Pokemon. We'll give it, anyone got a number that they want to know eventually what Pokemon it is? 12? Okay. And then so our function that we're creating takes two parameters, a number and a callback. Right now, we're not using the callback, so I'm still giving it a callback. This is the function that'll run when eventually the callback is used, but for right now, it's not doing anything. It'll just run this request, and it'll see if it's successful, and if it is, it's going to print out our little message there. So let's go into our terminal. We'll go node, who's that Pokemon, enter. So we did not get this status code. So sorry? It'll be a number. So if it's not there, let's console log status code. And let's see what happens. Oh, I maybe didn't save the first time. So request successful. So our program has run. It's made a GET request to this API /12. And then once that request came back, we have this response. And we're checking the response, see if it's successful. And if it was, we're logging that we have it. For our real application, we don't want to really be checking if it's successful. We really instead want to see if it doesn't work. Because if it's successful, then we'll just like return the stuff and we'll let the user who calls this function decide what they do with the information. But if it's not successful, we want to let them know right away. So we can do something like if it's not successful, we'll do a message request failed with status code, and then I can just tag on the code to the end here. So now if I change this to just some like gibberish, so the URL that we're making this GET request to should not work, we can see request failed with status code 404. So 404 is like the resource not founded. So it's doing what we want. We'll get rid of this. Save. So you'll get a chance today in some of your activities to work with this HTTP module that Node has. And one thing that you'll learn through doing this is that when we make a request with HTTP or HTTPS, the Node module, it gets the data that's returned, or specifically the body that's returned, in chunks. So in the real world, the resources that I request from a server can be really small or like really big. I could be requesting like a 4K image from a server, and if we think back to the metaphor of like the web being like a set of city streets, if I want to send that huge image in like one huge continuous set of data through this web, it's going to be really hard. It's like if the only cars that were allowed in like downtown Vancouver were like the biggest semi trucks that you could happen. Like traffic would be like super like miserable. It would be like super congested. If instead all the traffic in like downtown Vancouver was like smart cars, that's like much easier because we can leave each of the cars and make it easier for like everyone to get where they're going. The same is with like these HTTP requests. If I'm requesting information, it sends it in chunks, or like in it splits like the large response that needs to come back into smaller like manageable pieces that can be navigated through the web easier. But that means on my side here, I can't just say like just use my response now, because the response is only the initial chunk that comes in. And I need to actually use an event listener that takes, I'll explain this in 1 second. So with this response that I've been given in return from this HTTP request, it has a bunch of listener methods that I can call on it to know when things happen. So for this one, I'm saying for this response, when it receives data, then run this function. So when it receives a chunk, the next piece in line of the information that I'm requested, then I want to do something. The initial callback that I'm running here, this function, will run at the start of the request, And then here I'm saying for every next chunk that comes in, do whatever I have here. So it might help to visualize this a bit more if I print this out. So I have this listener that's saying when data comes in, I'm going to print that chunk and like also print a new line. So if we look here, we can see we got all this information back. And we can also see that there's these like new lines every once in a while. So every new line is like a new chunk that's come in. So this is like lots. But so it's also hard because the text is so big. But so starting here, starting at that new line, that's one chunk that ends here. Then the next chunk comes in, a big bunch of JSON information. It ends here. Another chunk, and so on and so on. Holy. So if we're getting all of these information back in like chunks at a time, and down here what we really want is to have the whole body, the whole response in one like one location, what might be a good approach to get all of this together? Because right now for each of these chunks, it's not stored, they're separate. Like I have one chunk here, and then the function runs again, or this event runs again, and I have another chunk, and then I have another chunk. But the current way I have the program, I don't have all of the information at the same time. So one way of doing this is to have a buffer, and a buffer, like when we're watching like a YouTube video and we see it's like buffering, it's taking all of the chunks that are coming in and it's adding it to one single location. So if I have one var data and I have it as an empty string, down here I can take this data, and every time a new chunk comes in, I can add on the next chunk. So as I'm going through, I'm saying, okay, here's, initially it's empty, the first one comes in, I add it on. The next one comes in, I add it on, it gets bigger, I keep adding it on. And so once all of these responses have, or once all of the data chunks have come in, my data variable should have all of the data in one location. So then, what would be the result if I console log data here? If I were to do this. Yeah. Okay. So that's our hypothesis. Let's give it a test. So we'll run our application. Oops, it's still clear. So we get data here, and then we get nothing. So why is that? So the reason is because we've started looking into this, but JavaScript is an asynchronous language, meaning that it will not wait on input and output, or it will not wait on things that it doesn't have to. It'll continue running. So I guess the common example is if we have a synchronous versus asynchronous restaurant, an asynchronous, or let's start with synchronous. A synchronous restaurant, your waiter would come up to you, they would take your order, and then they would go back to the kitchen and they would give the chef the order, and then they would wait. And they'd sit there, they wouldn't take any more orders, and once your food was done, they'd take your food and they'd bring it back to you. And then only at that point could they go and take the next person's order in line. This would be like really ineffective. I don't know any restaurants that like operate this way. All the restaurants that we've been to operate asynchronously. So the server takes your order, he goes back to the kitchen, he gives the chef the order, and then he can go and take another order from someone else. And only when that order finishes does he go back, pick up the order, and then bring it back to you. So asynchronous is also known as like non-blocking, and that's what is happening here with our event. So when we run our Who's That Pokemon function, it runs line 15, it makes the request. When the request comes back, it runs 16, it checks status code. If it's successful, it continues. Line 21, we make this variable data. Line 22, we make this event that is waiting for data to come in. Just like the waiter though, it goes to like the chef and says like, I'm waiting for this data order. But it doesn't then just sit on line 22 waiting until it finishes. It continues and is allowed to do other things. So it comes down and it runs line 26 and it prints out data here with the data object or data variable, which is currently empty. So that's why in our code we see data here and nothing. So this function, this event that we're waiting for, is running asynchronously. The callback only gets executed when chunks come in. And we have no guarantee of when that will happen. Maybe like the internet hits like a full congestion mode and it takes a little longer. Maybe it comes instantly, but we can't be sure that of when this will happen. So then it gives us the problem, how do we get our data that we've been buffering together, that we've been adding to a bigger chunk, if we don't know when these chunks are coming in, and we can't just use it after we've called it because it's running asynchronously. It's not waiting at this point to get the stuff back. The answer is there's another listener that we can use called end that will only be executed when all of the chunks have finished. So if instead of trying to console log down here, I move inside, we set up this one asynchronous function that waits for each chunk to come in and then runs everything that's inside. And then we set up this one that waits until all the chunks have come in and it will run everything inside here. So in doing so, this one's waiting, adding the chunks. This one's still waiting, but it hasn't executed yet. Once the last chunk has been added to data, then we're going to console log data here with all of the data. So if we save this and run it, we should, instead of seeing an empty string, we should get all of our data together. So we get everything here in one big chunk. Yeah, exactly. No line breaks. We have everything together. Any questions at this point? And again, this is like kind of our first introduction to using HTTP requests with Node. You'll be able to do more today, and the expectation isn't that like we can just all of a sudden replicate this. We just understand everything that's in here. It's just starting to get a feel for how we make these requests with our own programs, with our own Node programs. So at this point, we have all of our data, but instead of just console logging it, we want to return it to our function call so that we can do something with it. So here I'm going to say that our callback function that we're passing here is going to take one parameter data. And here I can say run the callback function and give it the data that we've just buffered all of the information into it. So instead of printing it out, it'll look the same, but now I'm going to print it out here. And we should have no difference. Yeah, same thing, but instead this time we're not doing any formatting inside of our function. We're saying that this function's purpose is just to give us the information. And then when we run it, we can take that information that we're receiving and we can like maybe do something with it. So the next thing we are going to want to do is we're going to check and try and use some of this data that we're getting. So I think because we're getting a specific Pokemon, we should be able to call, I think name is a key in our thing. But yeah, exactly. But let's test. I'm not sure if that's the correct way to get it. Undefined. Okay. I also think this is too much information for what we need. Yeah. So what we can do, so I can take this. Oops. V2. 12. So maybe we can look at this page to give us some more information. So it looks like we should only be getting this back, which is much smaller than what we're getting. And it also has a abilities, forms, moves, species type. Name. So we should be having a name property, but we're not getting it. So if we look at this huge response, it looks like we're getting more information than we want. So one thing we can do is we can check our path to see if it's correct. So we're doing Pokemon / number. We can try to append on a / afterwards to see if that completes the path. And we still get undefined. Oh. So what is our information right now that we're getting back? What have we stored it in? It's a string. So do you guys remember how to take a string and convert it back to an object? Yeah. So we take the data, we parse it, and then we will be able to call our properties on it. I'm not convinced that this is the only thing, but let's see. Oh, nice. So now we're getting the name back. Let's try and format this a little so it's a little nicer. So instead of just printing out the name, we can do, yeah. What did we, 12? Yeah, I think we were looking at like, let's see what 23 is actually. So this is with 23. It must have been like extra information on like, I don't know where that one came from. Nice. The last thing we can do if we want is we can have it so that the user can type in which number of Pokemon they want and have that give the response. Do you guys remember how to get the command line? And which one do we want to check for if we're second one? Okay. So let's say number, default number, we're going to do 25. And if we have one given, we'll set that. Instead of here, number, nice. So if we run a Pokemon and we give it what's another, there's like hundreds of them at this point, so I don't know if there's that many. Oh, Clang. Clang is the 600th Pokemon. Has anyone heard of Clang before? And then if we don't give it a number, it's going to use 25, which is a Pikachu. One thing though is what happens if we give it like, I don't think there's 1,000 Pokemon. If we give it like 1,000, so we get this error message. Oh, it actually gives us a 404 and crashes it. If we didn't want to have it do all that, we could let our callback have an optional error and the data. So when we're doing the callback here, there's no error, so we're going to give it null. But up here, when the request fails, we don't need that necessarily. We can run the callback and give it like an error, no Pokemon. So then down, so inside here we can check if there's an error. If error exists, then we want to console log. Do you guys? And else, yeah. In one of the early Pokemon games, there was like a glitch where you could run into this Pokemon, and it was called Missigno, and it was just like a bunch of like glitched out looking image, and that was because it was trying to like render a Pokemon that didn't exist, and it's short for like missing number or something like that. So in this case, we're gonna do the same thing. If the Pokemon doesn't exist, we're just gonna say It's missing no. So we'll try 1,000 again. Oh no. Pokemon is missing no. Undefined. Not found. So we're getting this, and then I'm just going to zoom out a little bit. I think after we do the callback, we're going to return so that nothing else in this function gets run. Because right now we're getting an error and then it's trying to do extra stuff. So let's see if that works. Yeah, there we go. Request failed, status 404, Pokemon is missing no. So just a quick work through of like the flow of our program right now. So we're requiring HTTPS, which is a built-in module to Node that lets us make Node requests. We're building a function, and this function, we want it to make a request to the Pokemon API with a given number, and we want to return the information from that call. So we make the request, and we're specifying that it's a GET request, the HTTP method that we're using. We're giving it the path with the number that we want, and then once that request has been made, we have this response object that we can use. The first thing we can do is check the status code on that response object to see if the request was successful, and if so, we're gonna, we're checking if the request was not successful. And if it's not successful, we're letting the user know that it failed, and we're returning the function to the calling function. If it's successful, we're going to start a variable that we're going to buffer all of the data that's coming in chunks. To do that, we're using one listener on this response object, the data listener, and that's listening for any time a chunk comes in from the web of new information on this response. So we're taking all of those chunks and we're concatenating them together onto the data, and then once it's done, which we're listening for with another event listener, checking for the end of the response, we're going to call back with no error and the data parsed with JSON to the function that we've called. So where we're actually using this is we're saying we're going to look and see if the user has given a number. If they haven't, we'll just default to 25. We'll call the function, giving it that number, and waiting for the response, which will be error information and the data from the request. If there's an error, we're going to print out this information. If there's not an error, we can let them know what Pokemon was found. Yeah. Okay, so here we have a default number to use if no user input provided. So I'm just saying, I'm saying it, the number that we're going to use will be 25, and then if I'm giving it like 10, it'll use that instead. But if I don't give it any number, it just defaults to 25, and that's like Pikachu, I guess. Sorry? Yeah, and it kind of lets us have some default action if like no number is provided. If I didn't have this, then if I didn't provide a number, it might like throw up an error, and it's not necessarily like what I want. I could also have it check here if this exists, and if it doesn't, like I could say if yeah, exactly. Another option is here I could check if the number has been set or not, and if it does, I could just like not run the program, and I could just say like please input a number. Just different use cases on how I want to handle what the user does. Yeah, it could be 1 to apparently like 600 or however many there are now. Yeah, any other questions? Here? Yeah. Anytime, sorry, maybe similar. For this function, or any function, anytime it hits a return, it will return the value I give is what we've been using it for a lot, but it also just exits out of the function. So in this case, when I call who's that Pokemon, I'm not trying to get the value. Like if I was doing this here, I'm trying to store whatever comes out of that function call. But I don't care what it does at this point. So I also don't care what I return. I'm just using the return to say, like, let's exit, let's not do anything else after this point. Because otherwise it'll come down, if we have a bad response, it'll continue down here and try and do stuff. The other option, and maybe a cleaner one, is to do something like that, and then I don't necessarily need a return here. Nice. That's kind of everything I had to go over. Maybe just to finish, we can do a quick update to the list we made at the start. I'm not going to worry about that. Anything else that like we would want to add to these two lists? We can also add another one, maybe like network layers. Here. Sorry? Oh. Yeah. And that's kind of the only understanding we need. Like, we don't need to remember all the ones in between, but just knowing that there is this stack, there is this set of layers that build upon each other. Yeah. Yeah. Yes. Main one. Okay. Nice. So, yeah, that wraps it up. If you guys have any more questions, I'll be around. Come find me. I will be adding these notes so you have access to this program as well as all the notes we went through. So I'll try and get to that to you soon. Thanks.